So this is one security that has been taken in this question. And as you can see in the first column, we are showing probabilities. Remember that in case of probabilities, these are the expectations from the investor point of view, that what return he is expecting and what percentage of probability he is allocating to that particular return. For example, in the first case, if you see that uh, investor is expecting that return from this particular stock or particular asset will be 8%, and what probability is giving to this first one is 0.35. In a similar way, the expectation of return 10%, in this case the probability is given 0.3. So being a student, we can understand that probability should already be defined in the question if it is said by the examiner, or probability and the possible rate of return should be given. From practical point of view, probability will be a judgmental decision that is being taken by the investor or by the portfolio manager, depending on what capacity a person is working. So these probabilities are given. These are the possible return that we are expecting from this particular asset. If you are interested to get expected rate of return, so for expected rate of return, we need two information, one probability and the second rate of return. When we multiply these two we can get these values. You can check on your calculation. And after multiplication, if you get the sum, so this sum will be taken as expected rate of return. I'm hopeful that students who have done a basic probability and basic statistical courses, they are already familiar that how to calculate expected values. The similar technique will be applied over here. We will take probability, we will multiply it to 0.08, whatever answer is coming, get its total. So 10.3 is the expected rate of return from this particular individual stock. Or in other words, you can say that this is the average return that you are expecting from this particular asset. Now, this calculation is based on the portfolio of risky asset. In case of portfolio, again, we are doing this similar kind of work. These are the weights that are defined by the investor. In the previous lectures, we have covered this concept that how to calculate weight of a particular security in your portfolio. So weights are 0.2. It means that 20% of your investment is coming in first security, 30% you are investing in the second, and so on. These are the expected return that is available in your question, that these are the expected return you are expecting from the security 1, security 2, and security 3, and so on. If you are interested to calculate expected rate of return of a portfolio, so you will simply take the weight which is given and the security return that is expected from these securities, and then you will multiply these two one. So you will take weight, you will take return. Once you multiply it and gets its total, so this total would be taken as expected rate of return of a portfolio of risky assets. In simple words, if a person decided to invest in 4 different assets, and these are the percentages that he invested in these securities, and these are the return that he's expecting from these securities, once I multiply it and get its total, so from my total entire portfolio, I will be able to get a return of 11.5%. This is my expectation from my portfolio. In case if you are interested to calculate variance for standard deviation, in this case, keep it in mind that the basic understanding of variance in standard deviation we have already covered in fundamental statistical courses. The similar technique will be applied over here. There is no difference in terms of formula or calculation. You can simply do it on your calculator or on Excel spreadsheet, doesn't make any difference. So whether you are interested to calculate variance or standard deviation, you can use various tools, or you can use the previous formulas which was discussed in various statistical courses by your respected faculty members. Over here, I am showing you a simple working based on the data which is already given in the previous 2 slides. These are the possible rate of return which is given, and you can call it the expected rate of return that is given in the question. These are the expected security return that you calculated in the previous slide, and I can show you from the previous one. This is the expected security return that you calculated over here. The similar expected rate of return you will take, and these are the probabilities that you are expecting. You will take the similar one. So first I will take the possible rate of return. These are the expected rate of return given and calculated by you. Once you will minus these two one, so this column will be filled by you. So you will take 0.08 minus 0.103. Your answer will be minus 0.023. And once you get this one, you can take its square. So its square will give you 0.0005. And these are the probabilities that I discussed earlier should be given in the question. So when you will take this square and multiply by the probability, you will finally get the last information that is required to calculate variance and standard deviation. Once you take this square multiply by the probability, so this column will be finished and you will take its sum. The sum which is presented over here is, if we are taking it as it is given, then we call it variance, and if we are interested to calculate standard deviation, then we can take a square root of this information. So the standard deviation or the risk of this individual asset is coming 2.1237. Remember that this standard deviation will vary from stock to stock. So when you will move to portfolio, the standard deviation of that portfolio might be quite different from this one. That might be higher than this particular standard deviation, or it might be lower than this particular standard deviation. So whenever probability is given and expected rate of return you already calculated, possible rate of return are already given, you can apply taking these informations from the Excel, and you can get the variance and its standard deviation of this particular stock.